Hi, I'm Ziad Ali for Object-Oriented Programming. In this tutorial, you will write your first class in Java. We will introduce you to the concept of classes and objects. But before we do that, let's review the way you did programming in C++. Most probably you have done procedural programming before. You use primitive data types like integer, bytes, short, and sometimes strings. Used loops in order to repeat some steps, and sometimes you used functions and arrays. But you were working with small units, primitive data types, one at a time, like this. If you used an integer in Java or C++, integer x is equal to 10. So 4 bytes will be reserved in memory for the variable x, and the value 10 is stored inside them, one value at a time. If you print x, you will get 10. If you decide to change the value of x, then the old value will be removed and the new value will be stored in that memory location. Same thing if you use a double here. 8 bytes will be reserved in memory for the variable y, and the value inside it will be 4.5. Similarly, if you use a character, 2 bytes in Java will be reserved for the character code, and the code of that character will be stored, the number of the character. But you were working with one piece of data at a time. So, if you wanted to store some information about a student, like ID, name, number of hours completed, and GPA, you would have done something like this: integer for the student ID, a string for the student name, integer for the number of hours completed, and a double for GPA. You would print the contents of the variables here, the primitive data types. All are primitive except string, like this. Use println or cout in C++. You get an output similar to this. If you have two students, you would have done something like this. Create the same four variables for each student, like here, integer student ID 1, student name 1, hours completed 1, GPA 1, and then similar variables for the other student. This way of writing programs is not scalable because if you have 100 students, like in this example, you would have resorted to using arrays. Arrays, for example, you say the array size is 100, then you declare four arrays of four different data types, then ask the user to go in a for loop and input the data for each student. And you would go from the first to the last item in the array. And you know the array size is not dynamic, it's fixed and cannot change after you run the application. You would get some output like this. This is one array for IDs, another array for names, string array, another array for hours, integer array, and another array for GPAs, a floating point array. If you want to search a certain student, you would go by the index in the array, or by searching the ID, get the index of the ID, then print name and other information for the same student. You cannot insert in the array, you need to shift, which is a problem. These are some of the things that you would have done in C++ or any other language with primitive data types and what we call procedural programming. There are so many obstacles and limitations to this paradigm. Life is more complicated than just an integer and a string and a double for GPA. In real life, we work with things, we work with objects, with people, with cars, with students. So let's see the difference between working with objects and working with primitive data types. If I tell you a student is coming to visit, what comes to your mind? A student usually has an ID, has a name, college, university, a GPA, gender, and so many other attributes or properties or features or things that are related to a student. Let us simplify it. Let's say only four attributes for a student: name, college, and university GPA. This is a student, but not a specific student, not a particular student. In general, this is an abstract, a reference, a specification, a blueprint to the way we want to use students in our programs, for example, or in our application. So now we have four attributes: name, most probably is going to be a string, college is also a string, university string, and GPA is going to be a floating point value. If you want to create students in Java using object-oriented programming, now you will do it in a different way. You will not do the same way you did before. Here, when you created two students by creating the same four variables for each of them, or parallel arrays like this to create a long list of students, we would do it in a different way. So let's see this. These are the attributes of any student. This is not a real student. This is a reference, a definition, a blueprint of a student thing that we want to use in our programs. Real students are like this. This is Amina Business College in Stanford and her GPA is 2.6. This is Philip, studies law in Paris and his GPA 3. Aisha, science in Northwestern and her GPA is 3.1. And Martha, who is doing law at Yale with a very high GPA. Let's look at the difference between a class and an object. This definition of a student is our class. Those real students are the objects. They all have the same attributes. They all have name, college, university, and GPA, but different information. So each student has the four attributes, but different data. The class itself tells you the definition of a student, that a student must have a name, a college, university, and GPA. So if we look at this picture now, we would say the four students you see on the right side are objects that are created from the student class, and they all have the same attributes defined in the student class, but with different information. Let's do this in code in Eclipse. Here I am at Eclipse. I'm in a package called model. I'll create a new class. I'll call the class student. In the class, I will define my four attributes for each student. I will use string for name. I will use string for university, double for GPA, and let me say age, which is going to be integer. I'll make all my variables public and we will cover this in a different tutorial. I'll use integer or public integer age. That's it. Now I have a student class from which I can create any number of student objects. The class defines the attributes of a student. We defined four types of or four variables. Later we'll add methods and functions to the class, but let us at least start with variables now. How to create students? You just create any application with a main function. I'll call it student test. Student test. I'll go to the main function. Since we are in the same package, no need to do any import now. I will type student s1 equals new student. That's it. I created now a new student object. The object name is s1. All the contents are empty. Numerical variables will be initialized to 0. Boolean variables will be false. Other objects like strings will all be null. I need to set those values for the first student. S1, see if you press dot, you get the four attributes you specified in the class. Age is equal to 20. S1 dot GPA is equal to 3.4. S1 dot name is equal to Steve Jobs. And finally, S1 dot university is equal to Yale. So I have now filled all the four attributes of the student object S1. I can now create another student with different information. S1 is done. I'll create a new student, S2. This is a new object now, S2. And I can just here change to save a few seconds. I'll change the S2 and give different informations. So S2 age is 24. GBA is 2.4. His name is Bill Gates. And he is in Stanford University. Now I have two student objects. They all have the attributes specified in the class. I can print or change any of those attributes. Let me show you how to print one student object, for example. S1 dot name plus space plus S1 dot university plus space plus S1 dot GPA. I will do the same for S2. I'll just copy paste this and change the name of the object. Each object has its own location in memory, has its own version or copy of the four attributes. Run this, so I get Steve Jobs at Yale 3.4 and Bill Gates at Stanford 2.4. If you want to change any attribute, like here, I'll go and change the GPA of S2. S2.GPA is equal to 3.3. I can now show you that the data inside the object will change. If I run this, I change the GPA of Bill Gates. I can create many objects. Now I refer to the object, not to the individual primitive data type, not to the integer or not to the string. I use it from inside the object. I showed you a student class with 4 attributes. Is it only for data items like string and double and integer? Let us do some behavior. Let me provide a function or a method, public void get or get details of the student. In this get details, I will output the student information in a formatted form. Like here we'll say name, colon, percent, capital S, then comma, university, then percent, capital S, then comma, percent or GPA is equal to percent 0.2 F, and finally age is equal to percent D, and a new line after percent D. Now I can add the attributes here, the 4 attributes, which are name, university, GPA, and age. This method now was defined inside the class. Then it's available to all objects that are created from this class. Now, no need to do this type of print in your code. You just call it from the object s1.getDetails, and the code of the object will be executed and show its own attributes. Do the same thing for the other object now, s2.getDetails, and maybe we need to do it again after we change the GPA of Bill Gates. I'll call it getDetails. So let me run this now. So I get a nice and neat output. No need to do any code here. The design and the plumbing will be done in the class, and it's going to be available to all objects that were created from that class. If you want to change the get details to return a string, that's easy. You can just say string and use string format now. Let's say string details equals string dot format and return the string object to the function, return to the calling client, return details. So now you can use it inside the object as a string. So we'll go back to the previous version now, println, but however now you can just say get details, and the string returned from the function or the method will be s2 dot get details. You will see the method available somewhere here. Get details returns a string. So we'll do the same for all of them. Let me repeat this here and just change the object name. Run. So a string returns from the method of the student class. Let us see another type of objects. Car is another object. A car has so many attributes. To name a few: make, model, year, color, fuel type, engine size, and so many other attributes, or properties or specifications. To simplify it, we'll consider a car with only 4 attributes: make, year, color, and price. Make is going to be a string usually. Year is going to be an integer. Color is text. And price is going to be a floating point value. To the left side, you see our class. The class name is car. We have 4 attributes. From this concept or this definition, we will create objects. Objects can be like Opel. The make is Opel. The year is red. Actual information, real data. The color is red and the price is 21.30. The second one can be a BMW 1972 red, $3,000. So, two different objects, they have the same attributes but different information. And these are real cars in the streets. The one you see to the left here is a concept, is an abstract concept of what a car is, what attributes should be given to a car. A Mercedes 2015 Pearl Current $125,000. Another one is Cadillac 1963 with a pink color, $1,200. These are actual objects you see. You can create as many as objects as you want from the same class. Each object has its own data, but they all have the same structure or same attributes or same properties. Car is a class. From the car, we create objects. They all have the same attributes, but with different information. Let's go to Eclipse to write the class car. I am creating a class for the car object now. Car, 4 attributes as we saw. Let's say first, public string make. Second is public integer year. Third is public string color. And fourth is going to be public double price. 4 attributes. Save. I will create an app now to create car objects. I'll call it test car with a main function. I will do the same thing I did for a student. I'll say car C1 equals new car and then set all the 4 attributes of the car. C1 dot make is equal to Honda. C1 dot year is 2015. C1 dot color is white. And finally the price, C1 dot price is equal to $1,200. I can create another one now, another object. I do copy paste. You could actually get an input from the user and set these values to the attributes of the object. I'm creating a new car now. I will change the information. This car is now GMC and it's 2019 black and the price is 2300 890.50. You can change any attribute, you can print them. If you want to get a neat output, go ahead inside the car, provide a method public string get car details, and in this method do the same thing you did in the get details of the student. You could say here, for example, string details equals string dot format. Let's go one by one. first name or make, percent capital S, comma, then year, colon, percent D, comma, then color, and percent S, capital S. Finally, price and percent dot 2F, and then a new line, and close the string. So the attributes are going to be in the same order here. We will say make, comma, year, color, and price, semicolon. Now you can just go ahead to the test car and say sysout C1 dot, look for the function we did, get car detail, it returns a string, and do the same thing for the second object, which is C2. Let's run this. We have an error, unresolved compilation. So the function in the car has a problem, I believe here. Get car detail, public string. We do not return anything here, so I need to say return detail. So now our function returns the value. Let's run the code. So we get this output. So we created two car objects according to the definition in the car class. We filled data members or attributes with their specific information, and we used one simple function to get a neat output for the car. So the class and the object are like the cookie and the cookie cutter. The cookie cutter is the class, and the cookie itself is an object. From the same cookie cutter, you can create so many cookies. All have the same shape, but not necessarily same flavor or topping. So our cookie cutter is our class from which we instantiate multiple cookies. You can change the flavor, you can change many other things, but at least now the shape of the cookies and the size also is the same. Here are different types of cookies. They are of different shapes. Definitely they have been created with different cutters. If I look, so here we have only one cutter for each shape. You don't need more than one. And from that one cutter, you create as many as cookies as you want. If you want to make a change to the cookie shape, you change it in the cutter, not in the cookie, because the cookie is an instance of the cutter. The cookies we see here, they were all created with the same cookie cutter. However, they were given different toppings, coconut, icy, sugary coating, butter cookies. Here we have a different type of sugar coating. So all these cookies were created with the same cutter. The details are different. Exactly the same way the details of cars were different and the details of the students were different. Hopefully in this quick tutorial, you got the difference between a class and objects, how you can design classes, and how to instantiate objects from them in Java. This is only the very basics of object-oriented programming. See you in more tutorials.